Hey guys, welcome to our channel. So we've been decoding the agreed upon section of Bible changes. We've got our letters to go through all the categories. We've converted these to numbers, which I will provide a link, which we did that. And we have gotten our numbers to run forwards and backwards through stock market or finance, genetics, medical, and chemicals. And now we're doing atomic numbers. Now, I'm going to go ahead and say right away that some of these number sequences did repeat, and this got into being pretty involved, all right? So I did what I could, and I started skipping the repeating numbers because they just repeat, and but we did get through, so, oh, for anyone that wants to look and follow along at home, let's see, we can get this to where they're, yeah, right here. Right here is going to be, let's see if we can get them in the picture. These are the numbers corresponded to the letters. They run all the way across. They come all the way back and run across again. All right. And if you start, and I went all over the board with this one, guys, because atomic numbers are atomic numbers. So I couldn't pick a specified sequence because there are all sorts of sequences. So if you start with number 95, you end up with americium. And that is atomic number 95. All these are going to be on the periodic table of elements, guys, and it is a shiny radioactive metal. Silvery shiny radioactive metal. And we've had this before. It's commonly used in smoke alarms and stuff, batteries in the future. It's toxic due to its radioactivity. So you got a radioactive metal, guys, starting right away, number 95. If you go on from that, you get number 56, and that ends up being barium. And again, these are all periodic table of elements. And barium is a soft silvery metal that rapidly tarnishes in air and reacts with water. All right. And most is used in drilling fluids for oil and gas wells. It's also used in paint and glass making. We may have had this before. Barium carbonate has been used in the past as a rat poison. Barium nitrate gives fireworks a green color. All right. So you got barium. If you move on from that, you got number 17, which ends up being chlorine. And it is a yellowy green dense gas with a choking smell. It's used for killing bacteria. So I don't think I have to go into chlorine too much. I'll provide these links, guys. And we're also using DuckDuckGo as opposed to Google now. So if you move on from that, you end up with number 6, which ends up being carbon. And carbon there are a number of pure forms of this element, including graphite, diamond, fullerenes, and graphene. And graphene, one of my coworkers told me about. And there's all sorts of uses for it. But for the sake of time, because we got a lot, we're going to move on. And when you move on, you have number 55, which ends up being caesium. All right, caesium. And it is a soft gold-colored metal that is quickly attacked by air and reacts explosively in water. Uses drilling fluids, just like the other. So you got caesium. And we've had quite a few metals, right, in one gas. So that's interesting considering all the steel we got. But if you move on from that, you got number 39, and 39 ends up being yttrium, and that's its atomic number. It is a soft silvery metal, so more metal. Often used as an additive in alloys, it increases strength of aluminium and magnesium alloys. It is also used in the making of microwave filters for radar and has been used as a catalyst in ethene polymerization. Polymerization. It can also be used in lasers that cut through metals. Also in LED lights. So, and it can also be used to treat some cancers apparently, such as liver cancer. So, you got another metal. And if you move on from that, you end up with number 1, which is hydrogen. All right. I don't know that we have to get into hydrogen. It's a colorless, odorless gas. It has the lowest density of all the gases. So, you got your hydrogen here. I don't think I got to get too much into hydrogen. But if you move on from that, you got number 71, which ends up being lutetium. And lutetium, that's number 71, atomic number 71. It's a silvery white, hard, dense metal. Little used outside of research, so they say. One of its few commercial uses is as a catalyst for cracking hydrocarbons in oil refineries. Low toxicity, so you got another metal. And if you move on from that, you get number 7, and that ends up being nitrogen. All right, and nitrogen is another gas. So if you move on from that, you got number 11, and number 11, that ends up being sodium as an atomic number of 11. These are all atomic numbers. Sodium is a soft metal that tarnishes within seconds of being exposed to the air. It also reacts vigorously with water. So it's used in some nuclear reactors. But I think we all pretty much know what sodium is. And if you move on from that, you end up with 51. And 51 ends up being antimony. And antimony is a semi-metal. It's in its metallic form, it's silvery, hard, and brittle. It's used to make some semiconductor devices such as infrared detectors and diodes. All right. So that's one of the uses. But I'm really trying to get through this, guys, because there's a lot here. And again, these repeat at some point. So I think it was here. You end up with, if your next number ends up being 42, and the atomic number 42 ends up being molybdenum. Molybdenum. I could have been telling you when this stuff was discovered, 1871, but a shiny silvery metal. So there's another metal. All right. But if you move on from that, I'm not going to spend a lot of time on this stuff, guys, just because there's so much of it. You move on from that, you get number 85. And number 85 ends up being astatine. Astatine. It was discovered in 1940. And it is a dangerously radioactive element. There are currently no uses for this outside of research, so they say. Astatine. And if you move on from that, you have number 82. And number 82 ends up being lead. And I don't know that we have to get into lead. It's a dull silver gray metal. It is soft and easily worked into sheets. So, there's lead for you. Discovery date, ancient. Date, Discovery date ancient. But if you move on from that, you have number 5, and that's starting a repeat sequence. But I decided to do number 5 by itself, and you ended up with boron. And boron is a dark amorphous powder, and it's used as rocket fuel igniter and in pyrotechnic flares. Combined with sodium, apparently it's a flame retardant. So, and it's, it is essential for cell walls for plants. It's not considered poisonous to animals, but in higher doses it can upset the body's metabolism. So, alright, that's interesting. But if you move on from that, and now you've got a repeat sequence of 1711, and we already ran that. And so I just let that go and ran the next sequence, which was 117. And one atomic number 117 ends up being tennescine. All right. Oh, tennescine. I don't see my tennescine. There it is. It's just a little out of order. That's okay. But that's atomic number 117, tennescine. And it is a highly radioactive metal of which only a few atoms have ever been made, they say. And it's used in research, they say. And it was discovered in 2010. So, and if you move on from that, excuse me, 111 I did actually run first, so I actually ran these out of order, guys. 111 was before 117, but we ran 111 and got Roentgen, Roentgenium, discovered in 1994, and it is a highly radioactive metal of which only a few atoms have ever been made, so they say, and used only in research. All right, so then you had the 117, of course, but if you move on from that, you have number 19, which ends up being potassium. All right. Atomic number 19 is potassium, and it is a soft silvery metal that tarnishes in air within minutes. All right. Can be used in fertilizers. I guess I knew that. So it says it's essential to life, and it's found in all cells, so it is an important element. All right. And did I say metal? Metal. So lots of metals, guys. Lots of metals here. But if you move on from that, you have atomic number 21, which ends up being scandium, discovered in 1879. And scandium is a silvery metal that tarnishes in air, burns easily, and reacts with water. It's mainly used for research purposes. All right, and I'll let you read about it, guys, if you want to, but I am going to move on. And if you move on from that, you end up with number 4. And 51 repeats, guys. So that was a repeat. So we skipped over that because we already did 5, and we already did 1, and we already did 51, which was antimony. So we already got all that, and it repeated. So then, if you move past your repeat, you end up with number 4, and atomic number 4 is beryllium, discovered in 1797. And it is a silvery white metal. It is a relatively soft and low density. Yes. So it's used in nickel to make gyroscopes, with copper or nickel to make gyroscopes, springs, electrical contacts, spot welding electrodes, and non-sparking tools. It increases electrical and thermal conductivity. So, yeah, you got more metal here, and we're going to move on. If you move on, you have number 12, and atomic number 12 ends up being magnesium. I don't see. Yes. Yes. And atomic number 12 ends up being magnesium. It would appear I missed one, guys. And I apologize for that, but I'll get it here. So, anyway, you got magnesium. And that's going to be a metal, I can tell you right now. It's a silvery white metal that ignites easily in air and burns with a bright light. All right. And now we're going to remember that because I don't think I got number 94, guys. I'm not seeing that I wrote down number 94, but we're going to keep going. You got 36. Oh, because I did 29 and 41. That's why. Yep, that's what I done. Okay, it's all fine and well. You got 41, you got 29. All right, but 36 ends up being Krypton. You know, like Superman's home planet, I think. Uh, it's a gas with no color or smell. It does not react with anything except fluorine gas. So, you got Krypton there. You also have number 29. After that ends up being copper. And you can bet that's a metal. A reddish gold metal that is easily worked and drawn into wires. I think we all know what copper is. If you move on from that, you get 41, which ends up being niobium. And it was discovered in 1801. I know I haven't been hitting that every time, but I'm providing the links, guys. It is a silvery metal that is very resistant to corrosion due to a layer of oxide on its surface. All right, it's used in stainless steel and such. So you got another metal. And if you move on from that, you have number 23, which ends up being vanadium, discovered in 1801. I wonder if it's a gas or a metal. It's a metal, a silvery metal that resists corrosion. So, more metal. If you move on from that, you have number 63, atomic number 63 ends up being europium. And europium, discovered in 1901, is a soft, silvery metal that tarnishes quickly and reacts with water. So here you go, more metal. And again, we got a lot of steel hits in our chemicals, so this actually kind of makes sense that we're getting quite a few metals. But if you move on from that, guys, you get number, and somewhere this repeats again, but you get number 38. And number 30, atomic number 38 is strontium. And it's a soft silvery metal that burns in air and reacts with water. So there's another of your metals that reacts with water and burns in air. And if you move on from that, you end up with 59. And atomic number 59 ends up being praseodymium. Praseodymium? Praseodymium. Discovered in 1885, so it's an old one. A soft silvery metal. So another metal used in a variety of alloys and other stuff, guys. But if you move on from that, you end up with number 52 and atomic number 52. Got 52. Yeah, there it is. I just forgot to write this down, guys. But atomic number 52 is tellurium. discovered in 1783, excuse me. And it is a semi-metal usually obtained as a gray powder. So it's a metal usually obtained as a powder. And it's mostly used with copper and stainless steel to improve their mechanability. All right. And there's other uses for it too, guys, but we're going to move on. And you end up with number 12. And if I did not do this one before, which I may have already had, and I may have repeated one. But anyway, number 12, guys, if I hadn't done it before, is magnesium. And I'm pretty sure this was here before. Must be one that I just forgot. But magnesium is a silvery white metal that ignites in air and burns with a bright light. So, and if you move on from that, and somewhere in there, guys, there was another repeat, 95, and we got all that. I think we got 9 and 5 both. If not, I'll catch it on the way back, guys. But if your last number here, well, not this can't be the last number. You get 62, which ends up being samarium. And samarium is a silvery white metal. The only thing I can think is, okay, yeah, and then you're left with 23, which is a repeat. It's vanadium. So there's your repeat. And that takes you through going forwards through the atomic numbers. And some of that does repeat itself, so it's basically there twice. Not that it doesn't go through, it's just there again. So it definitely goes through forward, and we will see about coming backward. That's where we're at for atomic numbers. And then we will move on to technology and run that. But first, we'll have to come backwards through atomic numbers and see what's there. So we'll get to that as soon as we can. And we apologize for notifications not happening. We don't know why. We suppose it's a form of censorship of some sort. They don't really probably like the fact that we're digging into the Mandela effects. They probably don't like the fact that I know the moon landing to be BS. They probably don't like the fact that I know 9/11 to be BS, the official story. So they don't like any of that. And I'm sure they don't like me digging into the Mandela effects. So I'm sure there is somewhat of an attempt to keep our channel quite small, and that's fine. They can do that. They can even put a disinformation tag. I'll acknowledge it every single time. It's disinformation. That's what they're doing. Those tags that they put on people's stuff that, references you to Wikipedia, because that's a great source. That's all disinformation. That's all a bunch of BS. So that could be coming down the pipe. We're not 100% certain why they're doing that, or why you guys aren't necessarily getting the notifications, but and it's taken us a while to upload these too, so there's a number of factors here. So for now, guys, thanks for all your thumbs up, thumbs down. Thanks for your comments, leads, feedback, and subscriptions. And thanks a lot for watching, guys, and we will come out with part 2 of this as soon as possible. And for now, you guys have a great rest of your day.